Hello, students. Welcome to the course of ultrasonic testing technology. The main content of this course is AVG curve drawing experiment. In the previous course, we have already mentioned that the AVG curve is the curve describing the relationship between the distance, equal height, and the equivalent size of regular reflectors. It is often used to qualify the internal defects of forgings or castings. The drawing of AVG curve can generally be divided into two sections. The first section refers to the part with a sound path less than 3 n, and the AVG curve of this path should be obtained through the actual measurement. The second section refers to the part with a sound path or other than 3 n. When the sound path is greater than or equal to 3 n, because the difference between the theoretical calculated value of echo sound pressure of the reflector and measured value is very small, the AVG curve of this section can be obtained through actual measurement or theoretical formula calculation. The model of ultrasonic flow detector used in this experiment is CTS/22A. The model of probe is 2.5Z20N, and the test blocks are CS-1-6, CS-1-7, and CS-1-8. The parameters of the test blocks used are shown in the figure. The bottom of these three test blocks are all measured with 25 mm from the ground theta 3. The sound path of the flat bottom hole detection is 50 mm, 75 mm, and 100 mm respectively. This experiment will mainly explain two methods of drawing AVG curves. The first is the panel AVG curve, which can be directly drawn on the instrument oscilloscope panel. The other is conventional AVG curve, which is mainly drawn on coordinate paper. The drawing range of the AVG curve needs to cover the maximum thickness of the tested workpiece. In this experiment, the AVG curve with the sound path of 50 mm to 100 mm will be drawn as an example. Firstly, the drawing method of panel AVG curve is explained. It should be noted that the abscissa of panel AVG curve is the horizontal scale of the instrument oscilloscope screen, representing the sound path of ultrasonic propagation, and the ordinate is the percentage of echo wave height of a reflector. Place the straight probe at the center of the upper surface of the CS-16 test block. Radiate ultrasonic waves to the three flat bottom hole at the bottom. Find the echo of the flat bottom hole on the oscilloscope screen of the instrument. Slowly probe in the upper, lower, left, and right directions at the center of the upper surface of the test block until the echo reaches the maximum. At this time, hold the probe under constant pressure with one hand and adjust the attenuator and gain knob of the instrument with the other hand. to make the echo height of the flat bottom hole just reach the reference wave height, such as 80%. Use the pen to trace the first test point at the peak position of the flat bottom hole on the oscilloscope screen. Keep the attenuator and gain knob still to ensure that the sensitivity of the instrument does not change. Replace the test block with CS17 test block and continue the measurement. Make the echo of the flat bottom hole reach the highest value with the same method. Use the pen to continue to trace the point at the wave peak position of the flat bottom hole on the oscilloscope screen to obtain the screen test point. Change the test block again, measure the flat bottom hole at the bottom of CS18 test block, and draw the third test point in the same way. So far, the panel AVG curve from the 50 mm to 100 mm sound pass has been drawn. It should be noted that according to the relevant standards, when some sections of the AVG curve of the panel are lower than 20% of the panel height, in order to avoid missing inspection and excessive qualitative derivation caused by low sensitivity, the section drawing method should be used. That is to say, the part of the panel with wave height lower than 20% shall be redrawn under the condition of improving sensitivity so as to ensure that the lowest end of the curve is higher than 20% of the wave height. Of course, it is also necessary to adopt corresponding different sensitivities to carry out subsection detection in the later stage when using the subsection curve to qualify defects. Next, introduce coordinate paper AVG curve, which is similar to panel AVG curve. The difference is that the coordinate of the panel curve is the wave height percentage, while the ordinate of the coordinate paper AVG curve is the dB value. The specific measurement method is place the probe on CS16 test block to detect +3 flat bottom hole and find the highest reflected echo. Adjust the attenuator and gain knob to make the echo peak reach the reference wave height, such as 80%. Record the attenuator reading at this time, that is, the sum of attenuator coarse adjustment and attenuation fine adjustment readings recorded as dB1. Then the data of the first test point is 50 mm dB1. Test the flat bottom holes on CS17 and CS18 test blocks in the same way to obtain the data of the other two test points, 75 mm dB2 and 100 mm dB3. Trace the three data points on the coordinate paper and then connect them into the smooth curve to obtain a coordinate paper AVG curve to 50 mm to 100 mm. It should be noted that because the gain knob cannot be read, therefore the gain knob can only be used as to adjust the wave height when testing the first data point in this method. When testing other data points, the gain knob is not used and other data points are tested based on the same gain value. However, because the gain knob cannot be used, it may be impossible to adjust the wave height of 8% of the reference wave height by only use the attenuator. At this time, the interpolation method shown in the figure should be used to determine the ordinate dB value of the data test point. Well, the drawing of the coordinate paper AVG curve is over. Thank you for watching. Goodbye.